This lecture is looking at the law of sines and the law of cosines. We're going to go ahead and make a note about both of those. Get my little magic pen to work. There we go. So both the law of sines and the law of cosines can be used with any triangle. They don't just have to be a right triangle to use the law of sines or the law of cosines. So first let's look at the law of sines, which is a little bit easier and happier than the law of cosines. So the law of sines, oops, let's expand my screen a little bit more. There we go. The law of sines states that the sine of an angle over the side opposite that angle is equal to the sine of another angle in the same triangle over the side opposite that, which is also equal to the third side over the sine of the third angle. So recall that if we have a triangle and it's labeled ABC, its label comes from the vertices, the corners, and the side across gets the lowercase letter of the angle that's opposite. So again, it's easier now to see that sine of A over A is equal to sine of B over B, which is equal to the sine of C over C. So those are the relationships we're looking at. So let's look at a couple of examples that are all worked out for us. So our first example is asking us to find a missing side. Happily, it's labeled our triangle ABC for us, so it's a little bit easier to look at things. So since we have angle B and we have angle C, we're going to set up our proportion with B and C. So the sine of angle C over side C equals the sine of angle B over side B. So we're going to plug in the information we know. Angle C is 45 degrees, side C is 30 units, angle B is 74 degrees, so we have sine of 74 degrees, and side B is what we're looking for. So we're going to go ahead and cross multiply. When we cross multiply, this is our new equation. B times the sine of 45 equals 30 sine 74. We divide both sides by sine of 45, and then they already put it in the calculator for us, and we get B equals 40 times 8. So this is an example of finding a side. So here we have another example where it's asking us to find, again, a side. It's asking us to find side D. Side D is opposite angle D. And we have side E here, which is opposite angle E. So the first thing we need to do is find out what the measure of angle E is. And that's what they've given us here. Because the sum of all the sides in any triangle is 180 degrees, we can take 180, subtract the two angles that we know, and we're left with 58. So E equals 58. Now I can set up my proportion. So sine of D over D is sine of 82 over D, which is what we're looking for, and that's equal to sine of 58 over 24. We'll go ahead and cross multiply, then we'll solve for D by dividing both sides by sine of 58, and again they've done it in the calculator for us already. So you can see in both of these equations we're given two angles plus one side. to find another side. But we could also, if we wanted to, we'll go ahead and revisit our formula here. So we have sine of A over A equals, we're just going to use part of our formula here, sine of B over B. So here we've had two angles and one side to get a third side. But we could also have two sides and one angle to get a third side. So we can use our law of sines when we have two angles and one side, or we can use our law of sines when we have two sides plus one angle to find another angle. But in order to use this, the one angle that we have has to be opposite one of the two sides that we know, so that we can set up our proportion. So let's go ahead and look at some examples. So here we have an example where we're going to solve for side x, which is opposite 17 degrees. So I'm going to go ahead and write that in. Sine of 17 over x equals, and the other information I know is 72 degrees across from a 25 unit side. So I'm going to say it equals sine of 72 over 25. I'll go ahead and cross multiply. So I get 25 sine of 17 equals x times the sine of 72. Divide both sides by 72 to isolate my x. So I get x equals 25 times sine of 17 over sine 72. So let's go ahead and put all of that into a calculator. So do 17, I'm going to take my sine, I'm going to multiply that by 25. I'm going to divide that whole thing by the sine of 72, and I get 7.68. Or rounding to the nearest tenth, so I'm just going to get 7.7. So x equals 7.7. So let's go ahead and scroll down a little bit to do our next problem, our next two problems. So here we're looking for a side again. We have the angle opposite that side, so we can go ahead and start with that. So sine of 52 over x. I'm just going to go ahead and draw in a line here so that our work doesn't get confused. Equals, the other side I know is 20, so I'll put in my other side, but I don't know the angle across from that side. So we'll do some quick math. 180 minus 91 minus 52 equals, go ahead and use our calculator, 180 minus 91 minus 52 leaves us with 37. So I'll put in that 37 here. So this ends up being sine 37. So I'll cross multiply. When I cross multiply, I get 20 times the sine of 52 equals x times the sine of 37. Divide both sides by 37. So we get x equals 20 sine of 52 divided by sine of 37. So I'll go ahead and put that in my calculator. 52, take the sine of it, multiply that by 20, equals, divided by 37 sine and I get 26.2. So I'll go ahead and write that down, which equals 26.2. That looks pretty good. So if I know this is a 37-degree angle and this is a 52-degree angle, it would make sense that this would have to be a bit bigger than 20. So let's go ahead down now to the law of cosines. The law of cosines, again, is for any triangle, a right triangle or a non-right triangle. But you have to know 3 sides, or else you have to know 2 sides and 1 angle. So that information's here, and the reason why is because our options for the law of cosine all require 1, 2, 3 sides. Here's our sides again, and here's an angle. So we need to have 3 of these pieces of information if we're going to find the 4th. So here's our first example. We have 2 sides and an angle, and we want to find the 3rd side. Now notice in our laws, whatever side is on one side of the equal sign, on the opposite side of the equal sign, on the far end, the furthest opposite, is the cosine of that angle. So just like they're opposite in the triangle, they're also opposite ends of the equation. So that helps you to remember the equation. Whatever's over here is opposite the angle over here. So that's helpful for us here because we have our angle C and side C. So we can have side C squared over here. So here's our formula. We fill in our numbers. Side A is 12, side B is 10. So we get 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of 48. We can just put a square root around that whole quantity and put it into the calculator, and you get 9.1. We can also use the law of cosines if we have 3 sides and we want to find an angle. So in this case, they're asking us to find the measure of angle A. So since we're finding the measure of angle A, we're going to set up our whole equation with A squared on the far side. So we get A squared equals B squared plus C squared minus 2BC cosine of A. We plug in our values. So we get 7 squared equals 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of A. And then just to simplify our work, we're going to go ahead and multiply out those numbers. And then they skipped a little bit of a step here for us. They added together the 25 and 64. Then they subtracted that from both sides. So they were just left with negative 40 equals negative 80 times the cosine of A. Divide both sides by negative 80. So you'll end up with negative 40 over negative 80, which simplifies to 1/2, and it's still equal to cosine of A. Then to get rid of the cosine of A, you multiply both sides by inverse cosine, and you end up with the measure of angle A is going to equal the inverse cosine of 1/2. So you can put that into your calculator, and you get 60. So let's go ahead and take a look at another example we'll do together. So here I have 2 sides and an angle, and I need to find a 3rd side. And happily, the angle I know is opposite from the side I'm looking for. So I'm going to set up x squared as the side I'm looking for, because way out here on the opposite side, I'm going to use the cosine of 62. That's going to be on the opposite side of my equation. So let me go ahead and fill in what's in between. I get 12 squared plus 14 squared minus 2 times 12 times 14. So let's go ahead, start to multiply some things out. X squared equals 144 plus 196 minus 2 times 12 is 24. Let's just go ahead and do 24 times 14 equals 336. So minus 336 times cosine of 62. So let's add together our 144 and our 196. Actually, we don't need to. We can just put this whole thing as it stands in the calculator. So we'll add 144 plus 196, and that equals 340. We're going to subtract from that. I'm going to put things in parentheses again because my calculator doesn't work as well as yours. 336 times 62 cosine equals 182.25. So again, though, we had x squared. So I'm going to say x squared equals 182.26 when I round. X squared equals 182.26. Let's see what the square root of that is. Square root of that is 13, which looks really good with our diagram. So let's go ahead and write that down. X equals 13. Go ahead and go to our next example. Our next example, we're finding an angle. So we know eventually, when we're almost done with our equation, we're going to be using inverse cosine. But let's go ahead and set up our equation. Because we're looking for this angle, on the far left of our equation is going to be this side opposite it. So let's go ahead and start to write out our equation. And I have 10 squared equals 11 squared plus 12 squared minus 2 times 11 times 12 times cosine of x. So now we'll do some math. 100 equals 121 plus 144 minus, I'm going to use my calculator, 2 times 11 times 12 equals 264. So minus 264 times cosine of x. So let's start moving some things over. I'm going to subtract 121 and 144, both from 100. So I'll just go ahead and do that in my calculator. 100 minus 121 minus 144 equals negative 165. So I'll go ahead and write that down. Negative 165 equals negative 264 times cosine of x. I'm going to divide both sides by negative 264, so let's see what I get here. Divided by 264, we make that negative, equals, that's a nice number, 0.625, so go ahead and write that down. 0.625 equals cosine of x. Now we'll go ahead and take the inverse cosine of x then. So we end up with inverse cosine of 0.625 equals x. So I've got my number here. I'm just going to go ahead and take the inverse cosine of that. And I get that my angle equals 51.3 degrees. So I'll go ahead and write that down. Equals 51.3 degrees. Now if I had wanted to, right here, I could have actually, instead of getting to 0.625, I could have left things as 165. over negative 264 equals cosine of x. And then I could have taken the inverse cosine of both sides. So I ended up with x equals inverse cosine of negative 165 over negative 264. And depending on your calculator, you could possibly put this right into your calculator. Let's go ahead and look at another example. Here, we're asked to solve the triangle. That means they want us to fill in all of the angles and all of the sides. So we already have 3 sides, so we need to find one of the angles. Because we have 3 sides and no angles, we're going to start out with the law of cosines. So let's solve for, let's solve for angle A. So then this is side A. So 23 squared equals 17 squared plus 18 squared minus 2 times 17 times 18 times the cosine of A that we're looking for. So now let's do a bunch of math. 23 squared equals 529. I'm going to go ahead and write that down. 529 equals 17 squared is 289. I'm just going to go ahead and add that right now to 18 squared, and I get 613. So I'm going to go ahead and write down that 613. 613 minus 2 times 17 times 18 equals 612. So let's go ahead, write that equals 612 cosine of A. So I'm going to take my 529, I'm going to subtract 613 from both sides. I end up with negative 84. So negative 84 equals negative 612 times cosine of A. I'm going to divide both sides by negative 612. So negative 84 over negative 612 equals cosine of A. My negative symbols will cancel each other out. I'm going to take the inverse cosine of both sides. So I end up with A equals the inverse cosine of 84 over 612. So let's put that into our calculator and see what we get. 84 divided by 612, and now I'll do the inverse cosine, and I get 82.1 degrees. And that is the end of our review of law of sines and law of cosines.